Alright, so we're back. Same set of notes as before. We're just continuing on with the ions. So the last thing we should have taken a look at was that worksheet on subatomic particles, and then we're into ion charges. So we're going to go through a couple of different topics here just to kind of finish off. When atoms form compounds, they'll either want to take on extra electrons or they're going to want to give them away. So the charge of an atom is determined by adding the number of protons to the number of electrons. And if we can combine protons and electrons, if they're balanced out, we have an atom of it, gives us 0. If they don't balance out, that means we have an ion. Either something is positively charged or negatively charged. So if there's more electrons, like in the case of oxygen, for an oxygen ion, then the number shown is shown by showing the symbol and a charge with a negative sign. So here we can see that oxygen has 2 extra electrons in it to turn it into an oxygen ion. If there are more protons, then the same steps are followed with a plus sign instead. So in the case of aluminum, in order for aluminum to be stable in the shell that it's in, it needs to pick up 3 extra electrons and gain that 3 plus charge. And looking at the periodic table, there's kind of a little trick to go through if you follow the columns. We'll have to skip the transition metals because they can kind of go all over the place. But the first column, your alkali metals, they all have a charge of +1. Your second column, the alkali earth metals, have a charge of +2. And then column 13 has a charge of +3. Carbon and down in column 14, they carry no charge with them. They're in the middle. And then after that, following 15, 16, 17, it just goes -3, -2, and -1. So it just gives us a bit of a way that we can quickly see what the periodic table, what the charges are for different atoms. So after ions, then we can start to move into isotopes. It's possible for the same element to have different amounts of neutrons in its nucleus, and so that's something different than what we would have talked about from before. Isotopes are atoms that have the same number of protons, but they have different numbers of neutrons. And so we'll just move down to the bottom here so you can see the picture a little bit better. Let's take neon 20, 21, and 22 for instance. Notice that it kind of tells you the number afterward, and that number, the 20, 21, or 22, is the number of protons plus the number of neutrons added together. So 10 and 10 make our 20, 10 and 11 make our 21, and 10 and 12 make our 22. So when we start dealing with isotopes, remember protons never change, it's the neutrons that can change. So in this case, by looking at the picture, you can kind of see that this one has 10 protons, 10 neutrons on the left, but then in the middle we pick up an extra neutron, and on the right we pick up 2 extra neutrons. So you start thinking, okay, what does that do to the atom? Well, from a mass perspective, it makes it heavier, right, because we're picking up an extra neutron. It also is an extra neutron inside the nucleus, and so what can we start to do or expect with some of those things? And if you've heard of, say, carbon-14 before, carbon-14 just indicates that between protons and neutrons, it would have 14 overall as its atomic mass, and so specifically carbon has an atomic number of 6, so it has 6 protons, which means carbon-14, 14 minus 6 gives you 8, so it would have 8 neutrons in it. Carbon-14 is often used and referenced with carbon dating and trying to figure out how old things are, which is reliable for a few thousand years going through carbon dating processes. So I have a little table here. It's also in the handout section as well. So you can print off a copy instead of writing it all down in your book, but certainly if you want to, feel free to copy the chart into your notes as well. I would like for you to give this a try and see how you make out filling in the table. Take a look on the top, going through things like protons, electrons, neutrons, comparing the charge, and coming up with the atom or the symbol that's there. Kind of keep in mind with things that are given, like giving you hints like this saying iron 3+, that's telling you that it has a 3+ charge overall, which means in terms of protons and electrons, it would have 3 more protons than it would electrons. Also keep in mind when filling out the table that protons never change. Only electrons and neutrons can have different values. So give it a try. Pause this video and go through, and then when you're ready, we'll move on.